Hello everyone, welcome to today's class. So this is my second lecture on kinematics. So in previous class we have discussed till displacement. So today I am going to start with speed. Okay. So what is speed? So all of you might have heard about speed from class 9th. Okay. You guys have been reading about speed from class 9th and it is defined as the rate of change of distance. Okay. So simplest definition of speed is rate of change of distance. So what does this definition exactly mean? That you guys need to understand. It says that how our distance is changing with time. Okay, so that gives us velocity of a moving object. Okay, so this thing I am not going to get into deep into speed because these things you guys have already studied in class 9th in details, class 10th also. Okay, so few more things, and this is a scalar quantity. This is a scalar quantity. Why scalar? Because speed does not need direction. Okay, so formula we write speed is equal to distance upon time. This is the formula of speed. Okay, the term which we need to understand and study in detail is your average speed. Okay, average speed. The questions are going to come in your examination from average speed. They are not going to ask you to calculate speed normally. These simple questions are not going to get asked in JEE or NEET examination. Their questions might come from average speed. Okay, so the thing which you need to understand is average speed, and it symbol which we use is V, and here we write AVG. So it gives us average speed. Okay, and it is defined as the total distance traveled divided by the total time. Okay, so whatever the journey we have done, whatever total distance we have covered, we will divide it by the total time taken. Total time taken. Suppose I have started moving from point A to point B, then I moved backward to point C. Let's say this is 2x distance A to B and B to C is x distance, and the time taken from traveling A to B is T1 and from B to C is T2. Okay, now total distance traveled is going to be 2x plus x. Okay, 3x, and time, total time from here to here it took T1 time, and from point B to C it took T2 time. So the total time here will become T1 plus T2. So this is how we are going to calculate average speed. In average speed you need to see the distance first. Okay, I will tell you the type of the questions which are getting asked from this topic. Okay, so here whenever we are asked to find average speed, you need to find out first thing that the whatever the total distance has been covered and the total time that has been taken throughout the journey, and it is again a speed, so its unit is going to be meter per second and its dimension is going to be lt minus 1. So unit is same, SI unit is meter per second and dimensions is lt minus 1. Okay, all these things are known to you guys. Okay, now there are some cases. Okay, I will explain some cases to you guys now. So let's not get into these cases where it is turning back and everything. Let's take simple cases. Okay, first let's say let's take a particle which is present at point A and it moved to point B, and after that it moved to point C. Okay, so this is the path taken by an object and it has covered distance from A to B, B to C. Okay, so let's say here it has covered S1 distance and S2 distance, and the time taken to cover this journey is T1 and T2. So V average is going to be total distance covered. Total distance is S1 plus S2 upon total time taken. Up to here it took T1 time and here it took T2 time. So it is going to be T1 plus T2. Okay. So if they are asking you these kinds of a question where they are giving you directly the values of distance and time, then it becomes very easy for you guys to solve. Okay. But sometimes they are not going to ask you these direct questions, and what they will do, either they will give you time or velocity or distance or velocity. There you have to convert these formulas. I will show you now one more case. We have to find V average, and instead of time they have provided you with the velocity. Let's say they said that from moving from A point to V point, it moved at velocity V1, and from B to C it moved at velocity V2. Okay, so now they ask you to calculate V average. So how we will calculate V average? Here first we have to find V1, T1 and T2. Okay, because they have given us V1, we know that velocity is equal to distance upon time. Okay, so in this case, so time is going to be equal to S by V. But in this case, if you see here, time is T1, it is going to be equal to S1 by V1, and in this case it is going to be T2 is equal to S2 by V2. So this thing we have to use in V average. So when we are going to calculate velocity average, we will write total distance covered upon total time taken. So total time value is S1 by V1 and S2 by V2. Add them up, S1 plus V1 plus S2 by V2. So like these variations they can ask you in the examination, and you need to be prepared here. And here comes sometimes special cases also. Sometimes what they will ask you, let's say S1 is equal to S2. Okay, so they will say that in both the intervals the distance is same. So in this case this formula gets modified. So what will happen, V average is going to be S1 plus S2. Okay, let's say S1 is equal to S2 is equal to S. Let's take a value, S1 is equal to S2 is equal to S. Okay, now can I write here 2S? Similarly I can take S out, 1 by V1 plus 1 by V2 cancelled out. So 2 upon 1 by V1, 1 by V2. So this is a special case, and questions has come on this special case. Either you guys can remember these formulas, but I will suggest that remember the concept. Okay, if you remember the concepts, you do not have to remember these formulas. If you can remember the formulas, you good. Some students are good in remembering the formulas and some are not good in remembering the formulas. So it is totally on you guys, but these are easy things. Okay, so you guys can do these things. Okay, so this is the other case where they are providing you distance traveled and the velocity. Okay, and there should be another case where they are not going to provide you distance, they will provide you time and velocity. Okay, then how you will calculate, let me show you. So let's understand all the variations here. They will give you the time taken here. Let's say they are saying from A to B it has taken time T1, and from B to C it has taken T2 time, and it has moved with velocity V1 and V2. Okay, so similarly here I have told you V is equal to S by T, time is equal to S by V. Okay, so time is equal to S by V, but we already have time here, T1 plus T2 we already have. Do we have to calculate it? We do not have to calculate. But what does we need to calculate? We need to calculate distance. So though I am writing it upwards, so do not get confused here. Okay, so we have to find here distance. So S is equal to Vt. So here S1 is equal to V1 T1 and S2 is equal to V2 T2. So our V average will become total distance traveled. total distance traveled will be the sum of this one and this one, v1 t1 plus v2 t2 upon total time taken. Total time taken is t1 plus t2. Okay, so this is the formula here when they are giving you only velocity and time. In this scenario, you are going to use this formula here. So I hope all these three variations of finding average speed is clear to you guys. Now here again they can ask you that it has taken equal time, then again t1 will be equal to t2. Okay, so we can take it common here also. So what will happen if t1 is equal to t2? Let's say it is equal to t. So if it is equal to t, the t will come out v1 plus v2 upon 2t, cancelled out. So here v average will be equal to v1 plus v2 by 2. So these special cases, I am just telling you the formulas, but you guys do not try to remember them. Okay, just understand the concept so that you guys can apply these concepts in your examination. I hope it is clear to everyone. So let's move forward. Okay, so average velocity and velocity, oh sorry, average speed and speed we have studied. Next, the another type of a question which is getting asked, sometimes they ask you to find the speed at a particular interval. Okay, let's say you have started moving from the house. So all of you must know that how to drive. Okay, most of you students are these days are driving scooties and bikes. Okay, so there is a odometer in your bikes and cars. So it gives you instantaneous speed, means at any particular time what is the speed of your vehicle, it gives you that. And this is the question which is also getting asked. Sometimes they ask you to find the speed at a particular time, so that is your instantaneous speed. So next we are going to study instantaneous speed, and this is shown by odometers. I hope you guys are getting the feel of this thing, which what is average velocity speed and what is instantaneous speed. Okay, so here what we are getting, we are getting velocity at any time. We are going to get speed at any time. Like we have started traveling from t is equal to 1 second, 2 second, 3 second, 4 second, 5 second. Let's say at t is equal to 1 second, my velocity was 10 meter per second, and here 20 meter per second and 30 meter per second, 30 meter per second, 40 meter per second. So here I am telling you guys that when the time was 1 second, my speed was 10 meter per second. When my time was 2 second, here my speed is 20 meter per second. And at 3 second, the speed is 30 meter per second, and 4 second also 30 meter per second, and 5 second 40 meter second. So what are these speeds? These are instantaneous speeds. Okay, at every instant what was my speed. Okay, so this is the meaning of instantaneous speed, and you guys understand that it is a function of distance. Okay, means that with distance how it is changing, because if you know that the speed, it is a function of a distance. Okay, with time how distance is changing. Okay, so speed is a function of a distance, instantaneous speed is also a function of distance. And while studying integration, what did we learn? That when we were having these types of graphs, what did we do? We took a very small strip. Okay, this is what we have done when we studied integration. We took a small strip of dx width. Okay, and similarly here also when we have to find instantaneous speed, the distance traveled in that particular second will be small in comparison to the whole journey. Okay, this is the fact. Okay, let's say it has traveled for 1 hour, but we want to find the distance traveled in 1 second. Okay, so that is going to be very small. So similarly, here also instantaneous speed is found by dx by dt. We take a very small interval here and we write it like this: v instantaneous is equal to dx by dt, because we already know that speed is a function of the distance, and what do we check? How distance is changing with the time. But here we have to mark a very small change in the distance. Okay, why? Because we have to check at a particular instant, means very small interval of time, what is my speed. So at that small interval we will be covering very small distance in comparison to the whole journey, so it is going to be dx by dt. So I hope it's clear. And in exams the questions are going to come like this. Sometimes they ask you, let's say x, they will give you an equation like 3t square plus 4t plus 3. Okay, they will give you an equation like this and they will ask you find the instantaneous velocity at t is equal to 3 seconds. Let's say at t is equal to 3 seconds, we have to find the velocity. So when it is writing like this, means that at 3 seconds, particularly at 3 seconds, what is my velocity? So if we have to find particular velocity at a particular point, that means that we have to find instantaneous velocity. So what we will do, we will differentiate it. V instantaneous is equal to dx by dt. So here it will become d 3t square plus 4t plus 3 upon dt. Now it is equal to 3t square. It will become 60. 60 plus 4. Now here we have to find velocity at 3 seconds. Put the value of t 3. It will become 6 into 3 18 plus 4 22 meter per second. So this is the instantaneous velocity at t is equal to 3 second when it is moving with this function. Okay, so this is how we will be finding instantaneous velocity. I hope it is clear to everyone. So what you guys can do, you guys can construct these types of equations or your own 3 to 4 equations and take any time like 4 second or 5 second or 10 second, try to find, so that you guys will brush up your differentiation concepts also. So next we are going to start average velocity. So velocity, when here we have talked about only speed. Okay, why? Because speed is a scalar quantity. But let's move towards the velocity term now. Velocity, it is defined as the rate of change of displacement. Rate of change of displacement. Okay, now displacement is my vector quantity, so our velocity is also a vector quantity. So it is defined as displacement upon time. Okay, it is defined as rate of change of displacement, means that with time how my displacement is getting changed. Simple thing, just in both these things, in first case we were considering distance and in this case we are considering displacement. Okay, unit stays the same but it has become a vector quantity because it has direction and dimensions stay the same. Okay, so these are the basics which you guys have read in class 9th also. Now let's talk about v average and instantaneous velocity. Instantaneous and v average. So here V average velocity, again, like speed, average speed, we defined average speed was equal to the total distance traveled by total time taken. So here again the formula is going to be similar, but instead of distance we are going to use displacement. So it is total displacement upon total time taken. Okay, so total displacement here, let's try to insert vectors also here. What is displacement? How do we find displacement? Okay, displacement is find by the change in position. Okay, so can I write it like this? Change in position, change in position, and divided by change in time. So if I am writing total displacement as change in position and total time taken as change in time, it is right to say. Okay, let's say a particle has moved from here to here. This is its x initial position and this is its x final position, and this is its initial time and this is its final time. So change in position is going to be equal to xf minus xi, की final position minus initial position. Okay, so final position minus initial position divided by final time minus initial time. So I can write it like this also, ti, it is equal to del x by del t. Do you guys remember this? याद आ रहा है? Okay, it is a displacement. Okay, so here what is happening, the direction of the velocity is going to be same. Okay, let me explain. Here let's say this is my reference point. Okay, now this is my initial position, this is my final position. Now if I have drawn this vector now, origin now, let's say this is its r1 position vector, this is its r2 position vector. Now if you guys clearly see that this has moved from x initial to x final. Okay, so it has taken this path because this is displacement, this is going to be your del x. Okay, now we have to find here the direction of the velocity. Okay, so direction of the velocity is also in this direction. Okay, so direction of the average velocity is same as that of change in position, because change in position is also happening in this direction and direction of the velocity is also in this direction. Okay, I hope it's clear to everyone now. Now when we talk about instantaneous velocity, okay, when we are talking about instantaneous velocity, what do we have to do? Like previously said, we have to talk about a particular instant. Okay, now so far we have average velocity is equal to del x by del t. So here when del t tends to 0 means that it is very near to 0, means we are going to talk about a particular instant. So it becomes v instantaneous and it is written as dx by dt. It is easy. Baki all the concepts like your direction, they stays the same. Okay, so I hope it's clear. Now whenever in exam you are going to get a question, okay, in exam they are going to give you a question from this chapter, like they will ask you to find the distance and the displacement. So you guys do not have to go and start solving it first of all. What you need to see, whether a particle is changing its direction or not. Okay, why I am saying this? If a particle is changing its direction, then the value of the distance and the displacement is going to be different. Okay, let's say, because why I'm telling you, because we are studying this chapter motion in a straight line. Here, let's say a particle is moving from here to here, A to B. Okay. Now, if I ask you to find the distance and the displacement, you guys can clearly say that distance and displacement are going to be equal in this scenario. Okay. But here you guys can see, but in exam, what you are going to get? You are going to get questions in a different way. Like, if you see, they will ask you here x is equal to, let's say, 4t square minus 2t. Okay. Now here they are asking you to check whether it is going to reverse its direction or not. Why I am telling you about reversing its direction? Because if it is reversing its direction, means that it has gone to point B and moved backward. So if it has moved backward, then distance and displacement values are going to be different. So what should be our first priority here? First, we have to check whether it is changing its direction or not. Okay, let's see how to do that. Now this is displacement. Okay, let's find dx by dt, that is your velocity. Okay, velocity will be equal to 8t minus 2. Okay, now let's say at t is equal to 0, velocity will be equal to, when I am putting it 0, this portion is becoming 0, it is minus 2 meter per second. Okay, now at t is equal to 1, velocity is equal to 8 minus 2, 6 meter per second. Okay, now t is equal to 2, velocity is equal to 8 into 2, 16, 16 minus 2, 14 meter per second. Now at t is equal to 3, velocity is equal to 8 into 3, 24, 24 minus 2, 22. Now here you guys can conclude that this is moving, its velocity is increasing. Okay, now here we can say that its velocity is increasing. Okay, so what we can say, that it is not changing its direction. Suppose if its velocity was decreasing, so here we can see that first is minus 2, then 6, 14, 15, 22. Its velocity is not decreasing. Okay, so we can say that its direction is not changing. Okay, but here if you see, this is minus 2. What does minus 2 say? That it is moving, minus sign is representing that it is moving in the opposite direction. Okay, minus is only showing you the direction. Okay, but if you see t is equal to 1, just consider t is equal to 1 to 3, velocity is increasing in this direction. It means that at t is equal to 0 second, it was traveling at a different state direction. Okay, now Now let's take another case where it is going to change its direction. Let's say 8 is equal to 8t minus t square. So here what we will do, we will find the distance traveled by the particle at each instant. Now let's say at t is equal to 1, means that at t is equal to 1 second, the distance traveled here is going to be 8 minus 1, 7 meter. And at t is equal to 2 second, your distance traveled is going to be t is equal to 2, 8 into 16, 16 minus 4, 40, 16 minus 4, 12 meter. And at t is equal to 3 seconds, 3 seconds means that 8 into 3, 24, 24 minus 9. So 24 minus 9 is equal to 15. Okay, so x is equal to 15 meter. Now t is equal to 4 second, x is equal to 32, 32 minus 16, so it is 16 meter. Now t is equal to 5 second, distance traveled 8 into 5, 40, 40 minus 25, 15. So here you guys can see that the distance traveled is decreasing. Okay, means that here, let's say this is 0 and this is 50, 16. So you guys can see that at t is equal to 4 second, it was here, and let's say this value is 15, and at t is equal to 3, the particle was present at 15 meter. Now at t is equal to 5, again it is present at 15 meter. Okay, how is this possible? This is only possible if it changes its direction. Okay, it is reverses its direction. Okay, it is not going straight, it is coming backward also. Okay, this is only possible that. So here another thing which you guys need to understand here, that here when it started moving from here, it was moving with a certain velocity. Okay, now in order to reverse its direction, means that at time t is equal to 4, its velocity must have been 0. See, like if I am going straight like this, now I have to stop at a point first, then only I can reverse my direction. Okay, it is not like that I can start coming backward without decreasing my speed. Okay, so first my velocity will decrease and it will become 0, then only I can start moving backward. Okay, this is the simplest scenario. So can we say that at t is equal to 4, our velocity is 0? Okay, so this conclusion we can draw, at t is equal to 4, the velocity is 0. Okay, why I am telling you this thing, because here if you see at, if I ask you to find the distance and displacement traveled in 5 seconds, so now you guys know that the values are going to be different, because the distance traveled is 16 plus 1, 17 meter, but displacement is 15 meter only. Okay, so how we came to know about this thing? Whether first we have to find that whether it is turning or not. Okay, for turning a point, what do we need to see? We need to see at what time its velocity is becoming 0. Okay, so we do not have to do all these things every time. So there are shortcuts also. What we will do, we have to make velocity 0. Now what is velocity in this formula? Velocity, this is 8t minus t square, so velocity will become 8 minus 2t. Okay, now check velocity 0, find the time here, 8 minus 2t. So from here I can see 4 second. So it shows that at 4 second the velocity is going to be 0. Okay, same thing here, by this method also I have found at t is equal to 4, its velocity is 0. Now here also I have found velocity is 0 at t is equal to 4 seconds. So this is the first thing which you guys should always be doing. So this is my turning point. So whenever you are going to get a question in an examination where they have asked you to find the distance and displacement of a particle of a motion, the first thing what you need to do, you need to find the turning point. So when we will be studying your motion under gravity also, okay, there also you need to apply this concept, because in exam they are not going to ask you very simple questions, so you need to apply these concepts also. So what is the first thing which we will do? We will find the turning point. Okay, so I hope you guys have gotten the concept here, what I was trying to tell you. Let's do one question so that it becomes more clear to you guys. Okay, now let's say we are having an equation like 6t square minus 3t. Okay, and it asks you to find average speed and average velocity, time 0 to 5 second, time 0 to 5 second. Okay, now here two things are asked to us, average speed and average velocity. Now the time given is 5 second, 0 to 5 second. Okay, if this particle is turning its position, means reversing its direction, then the displacement value and the distance value is going to be different, so our average velocity and the average speed is going to be different. So for that what we have to do? we have to see whether it is reversing its direction or not. Okay, for that what we have to do, we have to equate velocity is equal to 0. Okay, now from here velocity is equal to dx by dt. Dx by dt is equal to 12t minus 3. 12t minus 3 is equal to 0. T is equal to 3 by 12, 1 by 4. 1 by 4 is equal to 0.25. So from there we can see that at 0.25 second it is going to reverse its direction. Okay, so distance and displacement is going to be different in this case. So this is how we need to calculate. So now you guys can calculate its distance and displacement. Now you guys can calculate average speed and average velocity. Try to solve this one and give its answer in the comment section. Okay, I have explained how this question need to be done. So I hope no one should have problem in calculating this question. Okay, so up to here it's clear to everyone. Now the next thing which we are going to study is your acceleration. Okay, so next we are going to start acceleration. Okay, acceleration, what is acceleration? Now in layman language, when we are driving, we are accelerating, we are giving a power to the scooty. We are just rotating our accelerator. Okay, and our scooty starts running. Okay, it starts gaining speed, our speed start increasing. So that is your accelerating motion. If your speed is increasing with time, okay, the concept here is that if your velocity is increasing with time, we say that it is an accelerating motion. Okay, what it is, change in velocity with time. Okay, and acceleration is written as, its SI unit is meter per second square. So I can write it like this also, meter per second by second. Okay, why I am writing it like this? Why? Because you guys need to understand this, that with every second how my velocity is changing, that gives us the acceleration. You need to feel this thing. Okay, like in your velocity, velocity was with every second how my distance is changing. Okay, now in acceleration it is with every second how my velocity is changing. So all the times we can see how things are happening just by seeing the diagrams. We do not have to solve everything. Let's say a body is moving, let's see here, body is moving at a velocity here is 10 meter per second. Now here acceleration is also 10 meter per second square. Okay, this is an acceleration of this body and its initial velocity is 10 meter per second. And if I ask you after 5 seconds what its velocity is going to be, what you guys will do, you guys will start solving it through the equation of motions and everything. But do we have to do that? We do not have to do that. Why? Because this is 10 meter per second, so at every second its velocity is going to increase by 10 only. So at t is equal to 0 second, if it is 10, and t is equal to 1 second, t is equal to 1, it is going to be 20 meter. T is equal to 2 is going to be 30. T is equal to be 4, 40. T is equal to be 5, it is going to be 50 meter per second. So this, from this we can just generalize this thing. Okay, from this thing we are generalizing that how my velocity is changing with time. Okay, that gives us the value of the acceleration. And we won't be solving this always, we can just see the diagram and answer these things. Okay, so in exam what you need to do, you need to save your time. How you are going to save your time? By just seeing these things. At every second it is going to increase by 10 second, 10 meter per second. Okay, so at 5 second it is going to be 10 into 5, 50. Direct answer. Okay, you need to save your time. This is your acceleration and its unit is meter per second square and dimension is LT minus 2 meter per second square. Dimensions are LT minus 2. Okay. Now the next thing which you need to understand is your average velocity. average acceleration. It is written as AVG, average acceleration. Now, how do we find average acceleration? It is again simple. V final minus V initial, final velocity minus initial velocity upon final time minus initial time. Okay, so this gives us the value of the average acceleration. This is again it can be again written as del V by del T. Okay, we can write it like this, del V by del T. Okay, I hope it's clear to everyone. And it is a vector quantity. Its value can be positive or negative as well as zero. Acceleration can be zero also. Okay, positive, negative, or zero. Okay, now let's me show you some things about acceleration also. Suppose a body is moving in this direction. Okay, this is the velocity direction and acceleration is also in this direction. Okay, now if velocity is in this direction and acceleration is also in this direction, in this scenario its velocity is going to increase. And if velocity is in this direction and acceleration is in this direction, or this is velocity, this is acceleration, or velocity is in this direction or acceleration is in this direction, in this scenario velocity will decrease. Okay, so here the concept which you need to understand here is that when the velocity and the acceleration are in the same direction, only in that scenario your velocity is going to increase, and when they are acting in the opposite direction, at that scenario the velocity is going to decrease. Okay, if I am writing it like this but both of them are in same direction, I can write it like this also, I can draw them like this also, but all of these are in same direction, velocity and acceleration. So in every situation here the velocity is going to increase, but minute the direction is changed like this, in this scenario velocity will decrease. Okay, why I am telling you? Because these things will be used in your motion under gravity, where you will see that I am projecting ball in this direction, the gravity is acting in this direction. So if you understand this thing right now, when the directions are changing, the direction is in opposite direction, the resultant velocity will decrease. Okay, now what we need to understand here is that when my velocity is decreasing, that means that retardation is acting. Okay, accelerating motion we call when our velocity is increasing. Okay, but while you are driving your vehicle, it is not like that. Your velocity starts acting in the reverse direction. Okay, let's say you are moving from here to here, A to B. Okay, here your velocity was also in this direction, acceleration also in this direction. At the point B you applied the brake. When you applied the brake, okay, your acceleration started acting in the opposite direction, but the direction of the velocity stayed the same. But after a while the velocity will become zero. What do you want to do? Why you are applying the brake? Because you want to stop your vehicle. Okay, so this is the scenario which happens here. So some students are confused and they say that velocity is also acting in the opposite direction, but here the velocity never acts in the opposite direction. It becomes zero. After that it can go in the negative direction also. Those cases also we will be studying. Okay, I hope it's clear to everyone now. Now let's discuss in how many ways we can bring a change in the acceleration. Okay, in how many ways we can bring a change in the acceleration. Now acceleration is equal to velocity dv by del v by dt, velocity. Now it is a scalar quantity or vector quantity? It is a vector quantity. So vector quantities are having magnitude. Okay, listen here, vector quantities are having magnitude as well as directions. Okay, Vector quantities have magnitude as well as direction. Okay, suppose a first case, acceleration. I am teaching you now in how many ways we can say that this is an accelerating motion. Suppose here an object is moving in with velocity 5 meter per second, but after some time its velocity is in becoming 10 meter per second, it is becoming 15 meter per second. So here we guys can see that magnitude of the velocity is getting increased with time. So we will say that it is an accelerating motion because change velocity is happening. Okay, so acceleration can be observed in an object if a change in magnitude of an object happens. Okay, so this is pretty much easy case to understand. The another case is that when, let's say, we are having an object, okay, A to B, it is moving at 10 meter per second. Okay, now at B it took a turn like this. Here its velocity was 10 meter per second. Okay, now after that C D, again it started moving at 10 meter per second. Now in this scenario, if we see, if when it was traveling from point A to B, its magnitude was not increasing. So till point B, we can say that it is non-accelerating motion. But as soon as it is reaching point B, it is changing its direction. So here at every point, we can see that it is having different directions. It is having different directions. So magnitude is not changing, but direction is changing. In A to B, neither magnitude nor direction was changing, so we called it as a non-accelerating motion. But in B to C, if you see that magnitude is not changing but direction is changing, so we will say that it is an acceleration motion. So acceleration can be produced by change in direction also. Okay, and your circular motion is always your accelerated motion. Let me show you how. Your circular motion is always accelerated motion. Now let's say a particle is moving like this. Let's say it is moving with a speed of 20 meter per second. Now it is moving with a speed of 20 meter second, but it is changing its direction at every point. Okay, though the magnitude is staying constant. Okay, magnitude is not going to change. Let's say at this point, this is moving at 20 meter per second. At this point also, it is also moving at 20 meter per second. At this point, it is also moving at 20 meter per second. Okay, now it is moving. You guys can take any point. At every point its direction is going to be different. Okay, at every point its direction is going to be different, so we will say that it is an accelerated motion. Okay, now can we say that, let me show you how do we write its velocity. Okay, now let's take a particle which is moving like this. A point, C point, B and D. Like this motions are happening. Okay, Now here we want to find the change in velocity, because in order to find acceleration we need to find a change in velocity. Let's say we want to find change in velocity from point A to C. Let's say here it is 10 meter per second. Here also it is 10 meter per second, 10 meter per second, and it is 10 meter per second. And how do we find change in velocity? That is del V, which is equal to V final minus V initial. And here the final position is C. But in this scenario, if you see, this is acting in your positive x direction, and here it will become 10I, then minus a. This is my initial position, but it is acting in the opposite direction, so it will become minus, not I, this is j, j cap, j cap. So it is equal to 10j plus 10j, 20j. Did it become 0? So this is an accelerated motion. If it has become 0, change in velocity is 0, then we will say that it is a non-accelerated motion. Okay, it should cancel out. So here directions are playing very important role. I hope you guys have enjoyed the lecture, and those who like my channel, please do like and subscribe. Thank you guys. Soon I will be uploading third lecture also.